here on latimes.com today. We're here talking about the mission to Mars, which is going to start in just a few hours. I'm Shelby Grad, and today we're joined by several Times reporters as well as an official from JPL, where all this Mars exploration is occurring from. And we'll talk about what's going to happen on Sunday night and some of the scientific discoveries they hope to glean from it. And I'm joined now by Times reporters Amina and Scott Gold, as well as by Ashwin Vasadava. Did I get that right?
Yep.
Okay, good. Deputy Project Scientist with JPL. Welcome all of you to the broadcast today.
Thank you.
Thank you. Thanks.
Okay. Well, Amina, let's start with you. You've been covering this for quite a while now. What exactly is going to happen on Sunday night?
Well, so on Sunday night, approximately around 10:30 p.m., the rover is going to enter the Martian atmosphere and land on the surface. And it actually is going to be landing in a way that we've never seen before, never tried before, because it's too big to use the airbag method that has been used for the previous two rovers, Spirit and Opportunity, which started roving in 2004. So I don't know if, Ashwin, you can talk a little bit more about that, but...
Yeah, we're landing in a brand new way. This is a 900-kilogram rover.
Wow.
That's about a ton, right?
I'm sorry?
That's about a ton, right?
Yeah, 1 metric ton. So, yeah, actually about a ton, no matter how you do it. 2,000 pounds. It's the size of a car. And all that means that we can't use the old systems we've had before, namely the airbags or landing on a platform and then driving off. This required several new inventions to get it down to the surface.
And I guess one of the things that I've been really fascinated by is how different and more advanced this rover is from some of the other ones we've seen on Mars in the past. Can you kind of describe the differences?
Sure. It really revolves around the fact that this mission brings really analytical chemistry laboratories down to the surface of Mars. We've had eyes on the surface of Mars. We've scratched and sniffed at rocks and soils, but we've never actually acquired samples of rock and soil on Mars and delivered them to laboratories inside the rover and then sent that data back to Earth. So when you're taking laboratories that would normally fill up a room in a university, down to the surface of Mars, you end up with a pretty big rover.
Wow. Well, Scott, let's bring you in. You've also been working on this for quite a while, and one of the things that I guess everyone is very interested in and very concerned about in a way is the 7 minutes of terror. Can you, Scott, describe what that is and how that has to do with the actual landing?
Sure. So Mars, the rover will be landing in a spot on Mars that's about 154 million miles away. And that's a great enough distance that a message that's sent from the rover back to Earth will take about 14 minutes to be received. So the rover will send a message to scientists back on Earth when it strikes the Martian atmosphere. And by the time scientists receive that message 14 minutes later, because the landing sequence, which is complicated but all happens in a fairly compressed amount of time, the landing sequence takes 7 minutes. So in other words, by the time scientists receive the message that the rover has entered the Martian atmosphere, the spacecraft will already be on the ground of Mars and will have been there for 7 minutes. And it will be another period of time before they start to get confirmation that it has survived. Mars is a notoriously difficult place to send a spaceship. In fact, JPL is the only institution on Earth that has ever managed to do it. And so there's a lot of concern because a lot of things have to go right in order for this to work. But that said,
Ashwin, how worried are you about these 7 minutes?
It brings out the human in you, and you have to put away your, it's easy to forget that you're a rational thinking person when you have to deal with the fact that everything you've worked for 8 years for me is all on the line in this very complex series of maneuvers that take the spacecraft down to the surface. The rational part of me knows that the engineering team here at JPL has done everything possible to test this vehicle, to design it in a way that's robust to almost everything we can think of. But that's kind of it. The thing that gets you are the things that we can't think of. The unknown unknowns is what might impact us on Sunday night.
And I guess the other issue that Scott wrote about in today's paper is the possibility of storms. Can you kind of explain how worried you are about those and what those are?
Sure. Yeah, that's been fun for me because much of the last 8 years has been an engineering show, and the scientists have been waiting in the wings to drive this vehicle around and do our stuff on Mars. But one of the things I've contributed as a scientist is predicting the weather on Mars. And that's been fun to work with the engineers and look at the data from our satellites currently at Mars to understand what the weather conditions will be like for landing. So one thing we are keeping track of are dust storms. Mars is coming out of southern winter, and that means we're going from a time that is usually pretty calm and clear to one that is characterized by these dust storms, which could be global in extent as we get later in the Mars year. So we're right at that boundary between clear and dusty, and we see these little storms springing up every now and then. We did have one spring up 2 days ago, and as of today, I can tell you that we're out of the woods. That storm is gone now, but we're going to keep looking out until we land.
Okay. Well, Scott, let's get back to you now. One of the things you've been looking into a little bit is exactly where the rover is going to land. And apparently that's a very interesting part of Mars. And can you describe that a little bit for us, Scott?
So other than making the decision to send the rover to Mars in the first place, arguably the second most important decision that's made here is picking precisely where this rover will land. And there were many passionate arguments that were made in favor of scores of different sites all over Mars. The one that ultimately rose to the top is a site that is an ancient geological feature, an impact crater called Gale Crater. The reason this was chosen, I think Dr. Vasadava can expound on this a little bit more, but the reason it was ultimately chosen is that this crater has a very large mountain in the middle of it, and this mountain, in one way or another, has been eroded over time and contains layers that are essentially a preserved record of the evolution of Mars, its environmental history, and ultimately its suggestions that it once had the possibility to foster life as we know it. So that is why this site contains enormous scientific possibility. And Ashwin, maybe you can expand on that a bit.
Sure, thanks, Scott. You know, I just want to start by saying it's amazing to me to be talking with the LA Times reporters who have covered us so nicely in the last few days. And you can explain things, you know, pretty much as well as I can. That's a wonderful thing, so thank you so much. The Gale Crater site is similar maybe to the Grand Canyon, where the early explorers who looked at the Grand Canyon and noticed that it was made up of layered sedimentary rock realized that that really turns it into a book of the Earth's history, specifically the history around the southwest United States. Now we're going to this place called Gale Crater with a mountain of layered sedimentary rock that's taller than the Grand Canyon is deep. This is in fact the largest geologic stratified, layered outcrop that we know of in the solar system. And the fact that we found it on Mars and that it dates back to that exciting time in Mars' early history when there was water flowing on the surface, and we think is the most habitable point in Mars history, means that we have this hypothesis that we're going to be able to land there and drive up those layers one by one and read Mars' early history like a book.
Shelby, I'm going to jump in here. My name is Michelle Malte. I'm with our social media team here at the Los Angeles Times. I wanted to invite our viewers to ask questions. You can tweet us at #AskLATimes, and we'll get to them as quickly as possible. I did want to ask, what is that behind you? I'm intrigued by that.
Yeah, let me get it. So this is one of Curiosity's wheels, hopefully not a real one. No, they're all in the spacecraft, but this is a replica of Curiosity's wheel. It's about half a meter across, which is huge. You can kind of get a feeling for how big the rest of the vehicle is from this wheel. We have 6 of these, of course. They have this tread to allow us to drive over the rocks and soils we think we'll encounter. And every wheel on the rover has its own motor and its own steering. Actually, the outer 4 steer, and all 6 of them have motors. So this is a very capable off-road vehicle, specifically designed to climb this mountain at Gale Crater.
How expensive was it to build the rover?
Over the past decade or so that the rover has been designed and built, the total is about $2.5 billion when you also include the rocket we used, the power source, and the 2 years of operations that are still coming up. So it's $250 million or so per year, which I'm biased, but I think that's a bargain.
Well, Amina, let's bring you in now. You've been looking into some of the potential science that can be yielded from this mission. Can you describe what the hopes are, and then maybe Ashwin can jump in as well?
Sure. Well, so we're on a broad scale. The goal of the Mars Science Laboratory is to look for what they call habitable environments, places where life could have existed. And so a place where life could exist needs the ingredients for life, and that is an energy source, certain organic molecules like organic carbon, and water. And this is all based on what we know based on life on Earth. So they'll be looking for those. They don't necessarily know that they'll find them all in the same place, but any hints that they have will be very valuable. So Ashwin, I don't know if you can expound on that a little bit.
Yeah, it's important. We want to communicate that we're not looking for life on Mars directly. That turns out to be pretty hard to do, for one. You'd need more than you can send on a rover to confidently detect life as we think it may exist on Mars. We're looking for very faint signatures, if anything. We're pretty sure after all the time we've spent on Mars' surface so far, there's no birds flying around or plants, but we're still confident that life in microbial form may have taken place. But to get back to curiosity, what we think we can answer more confidently is the presence of habitable environments. That sort of sets the context for whether life may have ever been there or not. In early Mars history, we think it was a wetter planet. We think the water was in a form that life can use. It was not too acidic. It was not, the temperatures were right for life. We want to confirm all those things by going to the site that has a geologic record of that time period. And we're also going to look for hazards to life. We have a radiation detector. We have an ultraviolet light detector. We'll be looking for chemical hazards that would rip apart organic molecules that life needs rather than preserve them and nurture life. So all those things, the negative side and the positive side of habitability, is what we'll be exploring with our huge scientific payload.
Is habitability also referred to the possibility of humans one day inhabiting Mars?
Most of what we're doing is understanding Mars as a habitat for microbial life, the kind of life we think may have taken hold on Mars at the same time life was originating on Earth. But we actually do have an instrument funded by the Human Exploration Office of NASA, the astronaut people, and that instrument is a high-energy radiation detector. For the very first time, we'll be measuring radiation on the surface of Mars after it's gone through the atmosphere and been affected by the atmosphere. And that'll tell us exactly how astronauts need to protect themselves when they go to Mars.
Describe the team you're working with. I assume this is a very large team working for years on this. Can you describe a little bit about your colleagues and what they're doing?
Sure. The bulk of the credit has to go to the engineers here at JPL and at other NASA centers who have put together this rover and the spacecraft that actually carries the rover to Mars. We've tried to add it up, and our numbers indicate that over 3,000 engineers at JPL have contributed, and perhaps as many as 7,000 when you include all the other small businesses and NASA centers and all the other institutions involved in the mission. So they've really got us to this point. In terms of the science team, we're about 400 people strong, all of them flying into Pasadena as we speak to get the keys handed to them by the engineering team on Sunday night. And this team is a lot of United States people, of course, but NASA these days collaborates on these big missions with other nations, and we have Canadians, French, Spanish, Russian, German, and many others as well.
Well, Scott, you've spent some time talking to some of the people who were on dealing with this mission and being there. What were your impressions? I mean, it's kind of hard to imagine the excitement after all these years that is finally about to take place.
Yeah, it's a pretty incredible team that's worked on this. JPL is a fun place to go to work because everyone there is very smart and very pleased to be doing what they're doing. Just like here at the LA Times, right?
Sorry, I'm laughing too loudly.
But no, it's fascinating to meet people. There's one gentleman I spoke to, for example, who's a scientist there, and he graduated from Georgia Tech 7 years ago and essentially has had one task since he finished his studies, and that is to build the largest parachute that has ever been deployed in space. And this parachute will deploy when Curiosity's spacecraft is traveling just under 2,000 miles an hour and will be virtually entirely responsible for reducing the speed of the spacecraft to a manageable speed, because Mars doesn't have enough atmosphere to do the trick. And so it's essentially one task that this scientist has been working on for 7 years, and it will either work or not in the space of about a minute. And you know, there's a $2.5 billion mission riding on the success of that parachute. And if that's the kind of thing that you find fun, then I think JPL is probably the place for you.
Yeah, and how about now? What can you describe some of the more as you guys are watching this? There's obviously going to be a lot of anxiety about this, but is there going to be some partying as well?
You bet. You know, if all goes well Sunday night, well, you know, I think we won't know what to do with ourselves. I honestly think none of us are really prepared for the emotions we're going to encounter, whether we succeed or not. I don't know. Watching the Olympics makes me realize there's a lot of other things in life that occur that you train many years for, and it all comes down to a few moments. You know, and this is certainly one of them, and I feel like I relate to those Olympians a lot more than I ever have watching them before. You know, it's only been 8 years for me, not since I was a kid, but still, 8 years of your life to come down to 7 minutes is a big deal.
Right. Well, Amina, can you lay out to readers and viewers who want to follow this? This all sort of begins late Sunday night, and can you lay out what the next few days after that are going to be like in terms of what we might see, data we might get from Mars, and then maybe Ashwin can join you on that one too.
Well, I can tell you a little bit about the first few minutes, I guess. So we'll be waiting for that first signal that has entered the Martian atmosphere, and that'll come around, I don't know, that'll be around 10:30, and then a few minutes after that, we will hopefully, if it lands successfully, get the first photos from the rover, and those will be from its 4 HAZ cams, and those are the cameras on the bottom of the rover on the front and the back, and they're actually usually just used to look for any hazards as it drives, but it'll be sending back some really small black and white photos to let us know that it's seeing well and it is where it's supposed to be. So beyond that, Ashwin, do you want to take off from there?
Sure. It is, you know, we do want to kind of set the expectations correctly. This is not the kind of mission where we're going to land on Sunday and then you'll see 360-degree color panoramas of Mars right away. And the reason for that is that this is a very complex mission, and we are in it for the long haul. You know, this is something we designed the last 2 years. Like we've talked about, the most complex spacecraft ever conceived and built at JPL. So we're going to be really careful. You know, we're going to be very deliberate in how we run the rover and check it out after we land. And so we'll be sending back those small hazard camera pictures, which are taken right after landing. And then each day for the first few weeks of the mission, we'll be checking out a different part of the rover, maybe a couple instruments each day, another subsystem of the rover like its computer, its backup computer, etc. And we'll sort of wind our way through the whole spacecraft, carefully checking it out, making sure it's all working well and we understand how it works on Mars, which is very different from how it may have worked here at the Mars yard at JPL. But we expect that we'll have some great pictures for everybody in the first few days, color pictures. And in the first week, we'll have a good panorama of the site that should show the mountain inside of Gale Crater off in the distance. Maybe within a few weeks, we'll have used all of the instruments and maybe sniffed some of Mars' atmosphere and maybe have something to say about the presence of methane on Mars, which is something that we've been interested in for its biological significance. And then a big event will be maybe a month or two in the mission when we analyze our first sample, which is really what we're going to Mars for with this rover.
Right.
You know, Shelby, if I may, there's a lot of interest here on Twitter and online in joining in. And how can people bite their fingernails with you guys, in addition to following on latimes.com, of course?
Yeah. You go there first, and then you go to any NASA website, whether it's www.jpl.nasa.gov or www.nasa.gov, and we'll be right on the front pages of those sites, and that'll direct you to links where you can watch a live broadcast of our landing starting at 9 p.m. on Sunday night Pacific time.
Okay. Well, let me ask you, Amina, and again, this is something where Ashwin can join in. We kind of talk about in the next few days, but this is really a mission that's going to last for a long time and potentially could be producing years of data. Could you kind of describe kind of what the timeline is in terms of what you expect from Curiosity?
Well, so this is actually going to be a 2-year mission, which is pretty exciting for the scientists because the last 2 rovers, Spirit and Opportunity, they were supposed to last 90 days, but their Opportunity is still going strong on the Martian surface. But that, basically just means that starting off, we have a very different timeline for what the research is going to be. So like Ashwin said, they're probably going to take their time on things as they go along because they know that they don't have to rush. And also the different instruments, you can't use them all the time. The chemical analysis, where it takes in a sample and ingests it and uses these spectrometers to look at the chemical makeup, those things can't be used every day. The cameras can, so those will send back data pretty regularly. But so basically, it'll depend on what they find. It'll depend on what's interesting, and it'll depend on what instruments tell them that maybe they should devote more resources to checking out a particular rock. Maybe they should shoot it with a laser. Maybe they should go and then sample it inside the rover's belly. So that's going to be the pattern of the next 2 years. And because it's powered by a nuclear, it has nuclear power, it may last for much longer than 2 years. But right now they have a 2-year mission. So Ashwin, I don't know if you want to fill in some of the details there.
Sure, and I think you covered it well. I'll just add that we of course want to make it over to the mountain inside Gale Crater. So we land in a relatively small, safe area. I say relatively small because all the previous landing systems couldn't have gotten us into Gale Crater. So we land in an area that's just a few miles across that we had to make sure was safe and flat. That area itself is pretty interesting. It's covered by sediment that came down from a channel once flowing with water in the distant past. So immediately Sunday night, we'll be on something that formed in water. But to make it over to the mound, we'll have to drive maybe 5-10 miles, depending on how far we land. And that could take several months to get over to the mound. So the science will continue to unfold. The first few weeks are scripted as we go through these very careful checkouts that we've actually rehearsed several times. After that, we're really calling this a discovery-driven mission. Every day, the science team will get together and decide exactly how to use the payload, how to use the rover to accomplish our goals of habitability.
And Scott, let me as we kind of sort of begin to round it out, Scott, maybe, and again, this is something that you can also join us with, Ashwin, is what is the biggest worry about what could go wrong? Is there any lessons from the last rover missions or about just things in your planning and contingencies that you sort of say, here are the things that could really make this not a good thing?
I think, like Ashwin said, the biggest sort of X factor are the unknown unknowns. There have been tests done on every facet of this for years now, but let me go back to the supersonic parachute that I mentioned earlier. So that parachute was tested in a massive wind tunnel up at Ames, which is another NASA facility, and they tested it a number of times. So they know that it can withstand the force that it's going to need to withstand to bring this spacecraft out of supersonic speed to a more manageable speed. What they don't know and can't really know until they do the live run is whether the parachute will deploy, whether it will open in the same manner above Mars that it opened here in the wind tunnel, because the atmosphere is 100 times thinner on Mars than it is here. And so that's an example of something where despite, they could have another 10 years to test this spacecraft, and they just still would never quite know the answer to that, and they won't know until Sunday night. Right.
Anything to add there?
I mean, I think that's a great example, and what keeps us up at night is that there's probably another many similar examples, stories I could tell about a particular part that we've designed as best as we can, but we're putting it on Mars. This is cutting edge stuff that we're doing that we've hardly had much chance to do as humans before, and we accept those risks because they're worth the the payoff of exploring another planet. I'll just add one thing about the science. We talk a lot about the engineering, which is really what's going to get us there Sunday. As scientists, we worry that the engineers could get it all right and put us down at this crater totally successfully, and we may not have thought about, there may be something unknown about Gale Crater that doesn't make it as an ideal site as we would have hoped. Or our instruments don't take the measurements as well as we hope to answer these questions. Again, we've done everything we can, but we are going into the unknown in the best way possible.
Okay, well, this has been a really fascinating conversation. Thank you so much, Ashwin, for coming in and talking with us, and Amina and Scott as well.
Thank you.
Thank you.
And Michelle, of course, thank you for being here. And thank you guys all for watching this Google Plus Hangout at LATimes.com. Of course, stay with LA Times throughout the weekend and next week for all the latest news and developments off this Mars mission. And, of course, go to the NASA and JPL websites as well to check out what's going on. And thank you all for watching very much.